Greetings and Assalamualaikum. We are Group 3. Today, we are going to talk regarding digital tools for tracking and optimizing sustainable supply chain performance. Our group member consists of Jian, Lu, Syabihah, Cuen, Sofea, and Chen. Next, I will talk regarding introduction. In general, the definition of introduction is digital tools are tech-based systems used to track, coordinate, and optimize supply chain performance and sustainability in real life. Companies are increasingly adapting this digital management system to enhance operational efficiency, accuracy, and eco-friendliness. This strategic shift is to manual operations are being phased out as they are no longer sufficient to maintain a competitive edge in the modern business environment. For the next slide, I will talk regarding the background of study. The background of study is a role of technology digital tools. Businesses use digital tools to track operations, boost efficiency, and reach sustainability goals. The research objective is to explore how digital tools enhance sustainable supply chains by reducing waste and environmental impact while improving resource use. The strategic value is to understanding these tools helps companies prevent error and make better decisions for a sustainable future.
Next, I will cover about the part 3 with the issue and finding. Then we will cover for 3 things with the 3.1, the convergence of the big technologies, 3.2, the institutionalizing the security via the DPP and digital twins, and the 3.3, tier BTP and the government, social governments. For the 3.1, is the governance of deep technology. This session discusses about how supply chain use the deep technology such as the AI, IoT, blockchain, and digital twins to improve the transparency and data reliability and the challenges companies face when they apply this technology in the real world operation. For 3.1.1, where is the supply chain transparency and the data integrity? In theory, the supply chain transparency improves the trust and accountability, especially through the blockchain, which they ensure the data integrity using the immutable records. However, in the practice, the companies often adopt the technology separately, creating the visual element instead of the full integrated and trustworthy system. Secondly, the real-time monitoring versus interoperability varies. Theoretically, the integration of the IoT and AI enables the continuous real-time monitoring of the material flow, emission, and logistic performance. But in the reality, the interoperability issues and lack of the standardization it prevent the smooth data sharing, especially across the multi-tier global supply chain. And for the last, digital twins and the adoption device. In theory, digital twins allow companies to simulate supply chain decision and reduce the operation risk. However, adoption is uneven, as the large company can afford this system, but well, the SME face a high cost and lack of technical skill.
So for 3.2 is about the institutionalizing the security via the digital product passport, also known as DPP, and the digital twins technology, also known as DTT. So actually, the smooth supply chain from a linear acquire, manufacture, dispose the model to the circular ecosystem of reduce, reuse, and recycles. The tools like the digital product passport (DPP) and the digital twin technology (DTT) are used to track the material flows, eliminate the information gaps, and for the recycling and stimulate the disassembly before the production to minimize the waste. So first, I would like to introduce what is DPP. So DPP actually refers to a machine-readable digital records which stay with a product throughout the product entire life cycle. So DPP actually is designed to solve the information gaps which will prevent the process of recycling. So in theory, digital tools should create a transparent pipeline for the carbon accounting based on the specific raw activity data like exact KWH use. But however, in reality, by 2025, 66% of companies still rely on the simple spreadsheets, forcing them to use the spend space estimates that fail to reward the actual green investment. Next, I will move to the digital twins. In theory, the blockchain creates the trueless verification system for social sustainability, which recording the workers' contract and the wage payment security. But in reality, this DDT in the reality is the garbage in, the garbage out problems, which the technology cannot detect the human concerns, where manager might force the worker to sign the falsified timesheets. So actually, in the theory, the DBP and the DDT helps to achieve the perfect security economies. However, there are three main problem that appears to prevent the achievement. So first is the data sovereignty, data secrecy. So the company are theoretically supposed to share the data and enable the security. But in reality, it fails the dominance. Manufacturers are terrified that sharing the detailed product composition data in the DPP will expose the threat seekers to the competitors. This will lead to a refusal to share the granular data necessary for the high value recycling. Second is the standardization work. There are no single global standard for DPP. The reality is a effect of Tower of Babel, where the different industry and the regions are developing the incompatible standards, making it impossible for a global recycler to scan the product from different manufacturers using a single system. Lastly, it is about the adoption lag. While the digital twins market is growing, it is used for sustainability is lagging. Most current deployment focus on the simple operational efficiencies such as warehouse throughput, which rather than the complex life cycle modeling and or security. Next, I will pass.
Yeah, I will continue about the 3.3, which is the deep tier visibility and the social governance. This session focused on the deep tier visibility, with especially tracking of the scope 3 emission and social governance issue. For the 3.3.1, where is the precision in carbon accounting versus the speed length of threat. Critically, the digital tools will be enables activity-based scope 3 carbon accounting by using the real supplier data. But in practice, many companies still rely on the speed-based estimate, which reduce the accuracy and fails to reward the green investment. Secondly, 3.3.2, which is the immutable trust versus the verified line. Blockchain is expected to provide tamper-proof social compliance record, such as the wages and contacts. But however, the technology cannot detect the human question, which allowing the false data to be permanently recorded as a verified. And the last, end-to-end visibility versus tier by spot. Finally, while the digitalization promises the end-to-end visibility, the transparency often stops at the tier 1, which is the supplier only. So the deep tiers remain as a blind spot, with the risks like forced labor or the deforestation are most like occur.
Okay, now I would like to explain the problem arise. There are 6 problems arise. The first one is high implementation cost. Digital tools such as IoT sensors, blockchain, AI analytics, and cloud system require high initial investment. Company must pay for hardware, software system integration, training, and maintenance. Large companies can afford these costs, but small, medium-sized enterprise often cannot. This creates a digital divide where only big company benefits from sustainability optimization. When some supply chain partners still use manual or outdated system, the data becomes incomplete and inconsistent, making sustainability tracking less accuracy. Second is cybersecurity and data privacy risk. Digital supply chains store sensitive data like inventories, records, supplier information, and customer details. As systems become more connected, they are more valuable to hacking and data leaks. Cyber attacks can damage their company trust and reputation. In addition, failure to protect data may violate laws such as Malaysia Personal Data Protection Act 2010, leading to legal penalties and financial loss. Third is data integration issue. Supply chain use different systems like ERP, WMS, and TMS, which often cannot share data properly. Different stakeholders also use different IT systems and formats. This lack of integration causes inaccurate reporting, poor decision making, and reduce the effectiveness of sustainability optimization. Now I will pass to the next person.
I will continue to explain the problem. The lack of standardized sustainability metrics. Digital tools such as carbon tracking dashboard and life cycle assessment software rely on consistent data inputs. However, sustainability indicators are often measured using different methods and frameworks. This reduces data comparability and reliability, making it difficult for companies to identify supply chain inefficiencies, benchmark suppliers' failures, and make accurately sustainability decisions. Resistant to change. Management may worry that digital tools will temporarily disrupt workflows and reduce short-term productivities. At the same time, employee often fears the uncertainty brought by new technologies and prefer manual processes. This resistance slows down digital adoptions and result in delay or inaccurate sustainability performance tracking. The final challenge is the lack of the technical skill. Rapid technologies advancement has created a skill gap as training and education systems struggle to keep out. Without skilled professionals, organizations cannot fully utilize digital tools, reducing competitiveness and limiting the efficiency of sustainability initiatives. Thank you.
Yes, I will explain the future impact of digital tool in sustainable supply chain management. We have a two perspective, manager perspective and industry perspective. Next, for manager perspective, we have enhanced supply chain visibility. In the future, manager can see supply chain activity in real time. This helps them make better sustainability decision. For example, checking supply chain compliance and carbon emission. Number 2, proactive decision making and risk management. The digital twin help manager predict problem before they happen. So, manager can plan yearly and reduce delay and waste. For example, predicting supply delay and adjusting inventory early. Number 3, life cycle tracking and circularity DPP. DPP help manager track product from start to end. This also support recycling and follow sustainability rule. For perspective industry, number 1, better ESG compliance and transparency. Company can track emission and social practice of supplier. This improve transparency and ESG reporting. For example, using sensor to monitor energy use at supplier factory. Number 2, industry-wide traceability and circular economy. DPP help industry track recycle and sustainability product. This also help company meet regulation and improve their image. For example, tracking recycled material used in product. Number 3, data government and cybersecurity. Good data control keep sustainability data accurate and safe. This also help prevent false or incorrect information in digital tools. That's all for me.
Next, I will explain about conclusion. Digital technologies allow businesses to make early choices rather than just responding to issues late. Digitalization increase efficiency, coordination, and stability, helping companies respond better to market shift and environmental restriction. These technologies are essential for developing transparent, reliable, and sustainable supply chains that meet both commercial and environmental goals. That's all from us today. Thank you.